Okay, hi everyone. Welcome back to the second part of the topic on engineered field or engineered earthwork. I'm sure you have gone through the previous videos on the first part of this subject. Altogether, there were 3 videos. I'm sure you have gone through them, and today we are going to continue with the remaining parts of the topic, which is basically on site procedure and the work verification. The previous part was on basically to establish the benchmark for the site work, and this time it'll be about the site operation. So you can see that I have prepared the slides in 2 major groups, but later on you will see that. One is the site procedure itself, and then the second one will be on the site verification. For site procedure, we are talking about how are we going to do the work on site. Basically, it can be summarized into this list. First is soil is brought to site and compacted in layers of between 200 and 300 mm. And second, we need to do constant check of the field density to ensure the compliance. And then at the same time, we must be careful. We need to take care of the rate of construction, especially on embankment work, to avoid any embankment failure because of the pore pressure build up in the foundation soil, especially the clay soil. And then, of course, the type of roller that we use, it can be, if you use heavier roller, it will give a better compaction. And finally, what kind of work verification? We need to do work verification that we have completed on site for certification and handover. So let us go into more detail on this list. Okay. For the first one, we are talking about the soil is normally brought and spread in layers and compacted in layers of between 200 and 300 mm. This is to ensure we achieve a proper compaction according to what it was intended. And on each layer, there will need to be a verification. That means you need to do the test. You need to do the testing to verify the compaction effort that you have made, whether it has achieved what it was planned or it was intended in the specification. Of course, if your field would go higher and higher, each and every layer need to be tested. And this test, like I said before, usually it requires a certain interval if you're talking about a linear type of project, or if you're talking about site project, in certain area of certain amount of area need to be verified by the test, by the test that has been specified in the specification. And then but as you can see, sometimes the first layer, when you do a site operation, sometimes the first layer cannot be too thin as we can see here, 200 to 300, maybe too thin for for the construction vehicles to go in. Usually the first layer is allowed to be spread in slightly thicker layer depending on the foundation soil that is existing on site. But of course, the consequence, the subsequent layers will need to be according to this thickness that I mentioned here. And then what exactly is the thickness? You need to refer to the contract document and also the specification that you have. This is the most common thickness that is practiced on site. And of course, like I mentioned just now, this constant check of field density need to be carried out to ensure compliance. On the left is a type of field density test that is being carried out for site operation like this, like on the right here. And like I said just now, it needs to be done on every layer of finished or completed field. Another thing that need to be is of concern on site is care during your work operation on site, because sometimes rates of construction in embankment work, especially on clay foundation, need to be controlled to prevent the build-up of pore pressure, like I mentioned just now. If the pore pressure has gone too high, it may cause the failure. You imagine when the soil is in such a stressful condition, just like us, human, when we are under stress, the ability for us to handle more pressure could be jeopardized and it can cause failure. Same thing with the soil. You can imagine the soil down here, the green one is the clay. If it is, if this embankment, the yellow one has gone too high, too fast, it may cause may accelerate the build-up of the pore pressure within the clay soil down here. This is the clay soil. This is the embankment. Oh, sorry. And then if you go too fast, too high, it may cause the embankment to fail because of the support from the soil down here will be because the clay can no longer support the new field or embankment that we bring to site. This actually there is a what we call it a rule of thumb of preliminary you can say guesstimate of how high can we go to ensure there will be no excessive pore pressure build up in the soil down here. Okay, this is over here is actually relationship of what is the height. It says here height of failure, and on the right is 5 multiplied by SU. SU is the shear strength of the soil down here. Where do we get the shear strength value? It is from soil investigation, or from other empirical assessment, and divided by the density of the field, density of this field here. Then we can estimate what is the height that we can that we should not go beyond before we let the pore pressure within the clay soil dissipate. Those things, of course, needs monitoring. On site, there will be a monitoring instrumentation that will indicate the condition of uh, is pore pressure within the foundation soil. When the pressure is too high, you should stop the work, the embankment work on site. Otherwise, there is a risk of what they call this failure in the supporting foundation. So this monitoring or instrumentation need to be monitored by people on site. So this is one thing that you need to take into consideration when you do earthwork operation on site, especially embankment on clay type of soil. You need to know what is the condition of pore pressure, pore water pressure inside the clay. We don't want the foundation to be overstressed that it will give way or fail in its support for the new embankment. You can see this is a embankment going forward, going ahead, and on the left here, you see there is already a failure, circular failure, sliding, because of the soil below the embankment has given way because of too much pressure from this embankment. This will disrupt our operation definitely, and then we need to do repair and things like that, which probably cost additional budget. Because when it happened, of course, it rarely happen, but when it happen, it can be news to your other team or to your company. Okay. Next one would be on the type of roller that you use on site. Of course, heavier roller gives a better compaction, like we have discussed before. But for embankment work, the best procedure is to compact a trial area first, a trial area, trial embankment, and measure the compliance. Why? Because this will help us to use a number of compaction or a number of roller passes that can be confidently applied to the during compaction. We don't have to do what I call with this trial embankment or trial area of compaction. It will give us some idea of how much compaction is required to achieve or to comply with the requirement or with the specification. So we will have a trial area and measure the dry density and whether the dry density has complied with the benchmark density that we have established in the lab, like I mentioned before in the previous lecture and videos. So when the relative compaction is satisfactory, the number of roller passes is used in the actual or in the remaining compaction. Let's say 6 roller passes are able to achieve that compaction requirement, then the remaining area within the site or within the embankment, we will use the same 6 time roller passes.